All right, guys, we're going to try to do this quickly because I want to do lesson 3-5 and lesson 3-6 together because we're getting close to the end of our unit and I want to make sure we have enough time to study for our final. So this is lesson 3-5 and today's lesson is constant of proportionality. Oops, that was not the highlighter. All right. Constant of proportionality. Moving down to the definition here. A constant of proportionality is a ratio between two proportional quantities. The two quantities should increase or decrease at the same rate. So for example, like right now, gas prices, as our gas prices have increased, our food prices have increased. Or number of apples on a tree. There would be an increase in the number of apples of trees as we increase the number of trees we have. So those go up together. Or even a simple one, if we're going to the movies, it's $12 per ticket. If it has a constant of proportionality, then I know everybody's going to be paying $12 for that ticket. It's a constant rate, which takes us to the next definition, which is rate of change. The definition for rate of change is how quickly one quantity changes in relation to another. So using the apples to trees ratio, my number of apples is going to directly be increased based off the number of trees I have. Or as I cut down trees, my number of apples are going to go down proportional to the number of trees I cut down. So then that would take us to our last definition, which is slope. Slope is the actual formula we're going to use to find the rate of change. We are going to divide the change in y, or our change in our output, divided by our change in x, which is our change in our input. So I'm going to go ahead and we're going to do some examples so that we can understand that vocabulary and what does it mean to have input and output. So when we talk about our constant of proportionality, you're going to see it in three different formats. You're going to see it in graphs, equations, or tables. Like you'll be able to find, it's going to ask you, what's the constant of proportionality? And it's going to have you either identify it in a graph, an equation, or a table. So the first thing I want to do is I want to have us draw a graph and see if we can identify our constant of proportionality. And I want to go back to using that tickets example with the $12 per movie ticket. So let's go ahead and set up a graph. If you remember, you have your X and your Y axis. So our X and our Y. And our X is going to represent the number of people that are coming into the movie theater. And our Y is going to represent the cost. Like how much is the movie theater basically getting for the number of people that are walking in. So if nobody comes in, and again, hey, coincidentally, X is our input, so this works well for our input-output. If nobody's walking into the theater, if 0 people are walking into the theater, then they are making $0. Okay? So I'm going to kind of label here. If one person walks into the movie theater, so we're at 1 here. If one person walks into the movie theater, again, they're going to be getting $12 per ticket. So if one person walks into the movie theater, they're going to be getting $12. So I'm going to label this graph. I'm going to go up by 10. So you want to make sure your graph, everything is constant. So my graph, I'm going to do by 10s, 10, 20, 30, 40, 50, 60, so forth. And then since this is number of people, I'm just going to label this 1, 2, 3, 4, and 5. So if one person goes in, it's going to be $12. So right here in between 10 and 2. If 2 people come into the movie theater, they're going to be making $24 right here in between. If 3 people come to the movie theater, 12 times 3 is 36. And you should be noticing something right now with the graph. If 4 people go in, 12 times 4 is 48, almost up to 50. What are you guys noticing with my graph here? The dots are forming a line. That's because it is a constant rate. Every person that walks into that movie theater, they are getting out basically $12. So every time it is going up by $12. That is a constant rate of proportionality. So how do you take this same example and make it into an equation? Well, I'm going to use my y and my x, so my y and my x, and keep in mind that our y is standing for money, our x is standing for people. So the equation would be y equals $12 times x. That's kind of our rule. In consonant proportionality, you'll see the term y equals kx or y equals mx. When you're doing linear equations, they're going to use m. So basically our rate of change is always going to be whatever number is here. That letter is how we're going to identify our rate of change. So if you think about it, if you think of this example, for every person that comes in, I'm getting $12, right? So if I have 12 times 1, if this becomes a 1, 12 times 1, the movie theater is getting $12. If I put in a 2 here, if 2 people walk in, I'm getting $24. So this rule, this rate of change is $12 per ticket. And that kind of matches. That's exactly it. There's our rate of change. And that takes us exactly down to our table. And how do we take all of this and put it all together in a table? Well, let me move this over a little bit. Again, this is going to stand for our x, this is going to stand for our y, or you could say this is our input and our output, and we're going to use our rule. If one person walks into that movie theater, the movie theater makes $12. If 2 people come in, the movie theater is making $24. 3 people walk in, the movie theater is making $36 because the rate of change is $12. So it's going to go up by 12 every time. So now this will be 48. And you can easily complete a table because we know that all we're doing is right here, looking again at this equation, is I'm multiplying it by 12 every time. So I'm just going to multiply my input by 12. So going back here, let's complete this table. For 5, it would be $60. And if 6 people came into the movie theater would have made $72. So you can see how all 3 of these methods, these forms, they all go together. So now I'm going to give you guys a problem, and I'm going to give you an equation actually, and I'm going to have you create the table and create the graph and see if we can do that. So let's do a really simple one with really simple numbers. Let's do, you are babysitting, and the people you're babysitting for, they tell you that they're going to pay you $10 per hour to watch their kid. So $10 per hour to watch their kid. So with that information, can you create the equation, the table, and the graph? And they should all go together. All right, so let me give us a little bit more space. So for our equation, I know it's going to be y equals $10 per x, or you could even say this is going to stand for money, the total money, and it's going to be $10 per hour. So that's your equation. To create the t-table, basically, I'm going to make my table go down because you're going to see tables both ways. So this is going to stand for our x, this is going to stand for our y. And again, our x is representing hours, and our y is going to represent our money. So if I work 1 hour, how much money am I going to be getting? $10. If I work 2 hours, $20. And I'm going to have you guys complete the rest of the table. If you work 3 hours, it's $30. 4 hours, $40. And then 5 hours, you'd be making $50. So now you can take this information and easily, you should be able to easily turn it into a graph. So one of my questions I'm going to ask you guys, the video is going to pause here, is what does the X stand for and what does the Y stand for in terms of our input and our output? Like, how would I label my X and how would I label my Y? You should note that the X, again, is standing for hours, and our y is going to be standing for our money. So when you go to graph this, it's really important that you create a constant rate. So for hours, I'm going to label this as 1 hour, 2 hours, 3, 4, and 5. There's no weird pattern. The pattern is constant. It's going up by 1. And then for our y-axis, I'm also going to keep a consistent rate, and I'm going to have that go up by what, guys? It should go up by 10. So 10, 20, 30, 40, and 50. So now when I go to graph my information, it will make a perfect straight line. If I work 1 hour, I get $10. If I work 2 hours, I get 20. 3 will go to 40. 4 is going to go to 40, and 5 is going to go to 50. And if you did it correctly, which my art is not so great, it should make a perfectly straight line, and it should go through 0, because if I didn't do anything, I made no money at all. All right, guys, so that's lesson 3-5. Go ahead and leave a summary for how to do the lesson, or if you have any questions or concerns, you can put that down at the bottom as well. And I will see you guys in class. All right, good luck on your con. Bye. Is finding proportions. So your objective is going to be, what is a proportion, and how does that relate to fractions, decimals, and percents, and how do I use proportions to solve real world problems?